Hello, these are the Unit 1 notes for significant figures, or sig figs. So sig figs are defined as all known digits plus one estimated digit. So it's referring to a measurement. Another way to think about that is whatever you're using to measure, you want to go one more decimal place than the smallest increment on the measuring tool. Okay, so for example, down here, say this is centimeters right here. There's only markings at like whole centimeters. So if you're measuring to this point right here, well, you know it's somewhere between 2 and 3. Well, now you estimate, well, it's about halfway, so I'm going to say 2.5. So the 2, we know it's greater than 2, but this 5 is your estimated digit. So this would have two significant figures in that measurement right there. Now you compare this to this ruler up here. Now it has increments every 1/10 of a centimeter. So now we can go one more decimal place. So if we say it's somewhere in here, we know it's greater than 2.5 but less than 2.6. And again, you estimate, well, how far in between? So we say 2.55. So that's what significant figures are. They tell you how precise the measuring tool is. Okay. All right, so what you're going to have to do is be able to look at numbers and tell me how many significant figures there are. All right, so the rules for that, we want to look at a number, and if you say all the non-zero numbers count as being significant, that's the easy one. Now with zeros, it's a little bit different. If you have leading zeros or zeros in front of the number, they never count as being significant. If you have middle zeros as in zeros that are between significant numbers, they always count as being significant. Trailing zeros are a little bit different. They count, but only if there's a decimal point. If there's no decimal point, then trailing zeros do not count. So this is an example down here. Middle zeros, sometimes they're referred to as in between zeros. All right, but we'll practice with this now. So here's some examples, and what you want to do is look at these numbers and just say how many significant figures there are. So if you want to pause it and try that out, because I'm going to go through the answers right now. Okay, so 60.5. All right, so anything that's not 0 counts as significant. So the 6 and the 5 count as being significant. This 0 is considered a middle zero, so that counts as being significant. So that has 3 sig figs. The next one, 0.0375. These are leading zeros. Leading zeros never ever count, so we don't count those, but you count the 3, the 7, and the 5, so that has 3 sig figs. 5,009. These zeros are middle zeros. Even though there's 2 of them, they're between significant figures, so they count as middle zeros. You can have a lot of zeros in there. It really doesn't matter. If they're between significant figures, they're middle zeros, so they always count. So this one has 4 sig figs. 4,350. So the 4, the 3, and the 5 count. The 0, this is a trailing 0, but it doesn't have a decimal point, so it doesn't count as being significant, so there's only 3 sig figs in that answer. Now you compare that to this one, 2.3600. Now these are trailing zeros, but now there's a decimal point in this number, so now they count as being significant, so now you have 5 sig figs. So that's kind of the main thing we want to be able to do with sig figs at this point, is be able to look at a number and just tell me how many sig figs are in that number. All right, now we also use sig figs to determine how we round off calculations. So you don't want to just take whatever shows up on your calculator screen and write that down. You want to be able to round it off to the correct place. So there's a couple different rules for this. The first one is for addition and subtraction. And the rule is the result has the same number of decimal places as the least precise measurement used in the calculation. So you look at the numbers that you're adding or subtracting together. So we have 1.24 plus 3.128. Now when you put that in your calculator, you get 4.368. But we want to round that off to the correct place. So the rule is you go by the least precise measurement. So this goes to the 100th place, this goes to the 1000th place. The 100th is the least precise, so that means we have to round off our answer to the 100th place. So we're going to round it off at this point right here. So the next digit is an 8. If it's 5 or greater, you're going to round it up, so it becomes 4.37. We rounded up 4.36 to 4.37 because the next digit was an 8. So that's for addition and subtraction. The next rule is for multiplication and division, and the rule is a little bit different. So the number of significant figures in the result is the same as the fewest number of sig figs in the measurement used in the calculation. So this doesn't go by the decimal place, it goes by the number of sig figs. So for this one example, we have 6.25 times 2.3. And when we plug that into your calculator, you get 14.375. Alright, now we want to go by the number of sig figs in the numbers that we calculated together. So you got 6.25, that has 3, and you have 2.3, that only has 2 sig figs. So the fewest number of sig figs is 2. That means we have to round this off to 2 sig figs. So you start on the left. So the 1 is your first sig fig, 4 is your second sig fig. So that's the point where we have to round it off. You look at the next number, it's 3. So 4 or less, we're going to leave that number alone. So this turns into 14. So we take 14.37 and just round it off to 14 because of sig figs. Now here's some more practice problems. And you should try to do these and round them off to the correct spot. And I'm going to go through the answers. You want to pause the video and try these out, because I'm going to go through the answers right now. Okay, so the first one, 1.8 plus 3.567. So with addition and subtraction, you go by the decimal place. So this goes to the 10th, to the 1000th. The least precise is the 10th. So we're going to round this off at the 10th. So the next digit is a 6, so we're going to round up that 3 to a 4. So it ends up being 5.4. This next one, again, subtraction. So we're going by the decimal place. So we have the 100th for this number, 1000th. The least precise is the 100th. So 2.622 will get rounded off to 2.62. Multiplication, we go by the number of significant figures. This has 3. This also has 3. So our answer that we calculated needs to be rounded off to 3 sig figs. So 43.5. We're going to round this up to 5 because the next digit is greater than 5. So 43.5. The next one is another multiplication, 5.2 times 8.456. There's only 2 sig figs in 5.2. So this is what we get in our calculator. We need to round that off to 2 sig figs. So we're going to round it off right here. The next digit's a 9, so we round it off to 44. Next one, we got 5.21 divided by 3.29. Both numbers have 3 sig figs. So when you plug it into the calculator, you get a real long answer, but we have to round it off to 3, so it becomes 1.58. The next digit's a 3, so you're going to leave that 8 alone. Then you have 12 divided by 29.3. There's only 2 sig figs in 12. This is the result in the calculator. So we're going to have 0.41. Again, the 0 doesn't count as significant. It's a leading 0. Those never count. So the 4 and the 1 are your only sig figs in that answer. Alright, so that's how we round off according to sig figs. And if you have any questions, there will be a couple of assignments with these significant figures, so you'll get some practice with that. But any questions, make sure you ask that in class or send me an email. Otherwise, that is all for the notes for Unit 1. Have a great day.